Hey everyone, this is Bhargav Suthar, and today we are going to learn about set theory. So basically this is the part 1 of the topic set theory. Now in this today's session we will discuss basics of set theory and some of the operations on a set. So first understand what is a set. Now what do you mean by a set? So it is a well-defined collection of objects is called a set. Okay, so objects can be anything. Okay, fine. For example, library, it is a set of books. Okay. Second example, classroom, it is a set of students, or it can be a set of whatever. It can be a set of chairs and so on. Okay, so classroom is a set of students, or classroom is a set of girls, or set of boys, or set of chairs and so on. Now there are various methods for describing a set. So the first one is this roster method. Now it lists all the elements in curly brackets. Simple. It is also called a listing method. We need to just list all the elements in a curly brackets. Now for example, this A equals to 1, 2, 5 and 6. So that's it. We are just describing it in a curly bracket and just list it out. Okay, so that is a roster method. Now the second method is set selector or set builder method. So it is a set described by some property which characterizes all the elements of the set. For example, this A equals to, we can say like this, set of all x, this column, such that, it means such that x square minus 3x plus 2 equals to 0. See, here we don't know what is the value of x. So it is just, it is described by some property. And it means that set of all x such that this x satisfies this quadratic equation, that is x square minus 3x plus 2 equals to 0. And what are the roots of this quadratic equation? And that is 1 and 2. Okay, so the answer is in set form 1 and 2, and that is the roster method. So this is the set builder or set selector method, and it contains some property. Second example, the set of all x such that this x is in between, or 0 is less than equals to x, less than equals to 10, where x belongs to n. So we here x is in between 0 to 10, and in addition x belongs to set of natural numbers. Okay, so how many elements will be there? Since n does not have 0, so the elements will be from 1 to 10. Fine. Now let us discuss some special sets. So n equals to set of natural numbers. Now set of natural numbers contains the elements from 1, 2, 3 and so on. Okay, then z is set of integers, and set of integers contains this 0, 1, 2 and up and so on, and minus 1, minus 2 and so on. Then this q, that is set of rational numbers. So it is a set builder form because we cannot include all the points in a list method. Okay, so that is some property thing. So set of all x such that x equals to p by q form. So x is of the form p by q, where this p and q both belongs to set of integers, and also this q, this denominator does not equals to 0. So it cannot be this infinite. Okay, then r, that is set of real numbers. So the real numbers are of the form set of all x such that x equals to a plus b root p. Okay, where this a, b belongs to set of rational numbers, and this p belongs to q plus. Now what do you mean by q plus? Q plus means set of rationals, but the positive rationals. Fine. And last, set of complex numbers. So that is a set of all x such that x equals to of the form a plus ib, where this a and b both belongs to the set of real numbers, and this I equals to square root of minus 1, and that is the complex numbers. Now let us understand what is a subset. So let capital A and capital B be two sets. Okay, now if each element of this first set A is an element of B, then A is called a subset of B. Simple. And it is denoted by this symbol. A is a subset of B. Okay, then what is a proper subset? So if A is a subset of B, so first A has to be a subset of B, and the number of elements in A and B are not same. So if both the numbers are different, then A is known as proper subset of B. For example, see, A equals to 1 to 5, 6. and B equals to 1, 2, 5, 6, 7 and 8. Now here you can see that all the elements contains in B, so that means A is a subset of B. So subset example is done. Now what do you mean by proper subset? So first it has to be a subset of B, then what is the second condition? The number of elements has to be different. So here you can see that here in A, how many elements are there? There are 4 elements, and in B, how many elements are there? That means 6 elements are there. So obviously they are different. So that means this A is a proper subset of B. Now what is equality of sets? So let us consider two sets. So two sets A and B are said to be equal if this A is a subset of B as well as this B is a subset of A. So in short, both the sets has to be subsets of each other. So then we can say that both the sets are same. Now let us understand what is empty or null or void set. So as its name suggests, empty means nothing, it contains nothing. So a set having no elements is called a null set or an empty set or a void set, and it is denoted by the symbol phi or just simply this curly brackets. Now for example, this set of all x, the set is set of all x such that x square plus 4 equals to 0 and x belongs to n. It is an empty set. How? See, x square plus 4 equals to 0, and also we have condition that x belongs to n. Now x square, if simply we have given this x square plus 4 equals to 0, then what will be the roots of this equation? It will be x equals to plus or minus 2y. So that won't be an empty set. But here also the condition is x belongs to n. So that means x has to be from natural numbers. But I does not belong to natural numbers. So that means the set, the given set is an empty set or it contains no elements. Now let us understand what is a universal set. So a non-empty set of which all the sets under consideration are subsets is called a universal set. So it is denoted by this symbol U, capital U. Now what is an ordered pair? So let capital A and B be two sets. Okay. Now let A belongs to A. So let some element belongs to the first set and the second element, this B, belongs to the second set. Then if we combine both the elements, that is AB, just bracket, small bracket AB, is called the ordered pair, where this first element comes from first set and second element comes from the second set. Okay, so where A and B are first and second coordinates respectively. Now what is a Cartesian product? So let capital A and capital B be two sets. Now the Cartesian product, it is set of all distinct ordered pairs in which the first coordinate is from set A, that is the first set, and second coordinate is from the set B, that is the second set. Okay, so and it is denoted by this symbol, this A cross B, and it is defined as set of all x such that this ordered pair AB such that this A belongs to A and B belongs to B. So just collect all those elements in which this first element comes from first set and second element comes from second set. For example, if we have this A equals to 1, 2 and B equals to AB, okay, then what will be the A cross B, that is the Cartesian product. So A cross B will be like this. Just take 1. So the one, just fix 1. So 1A, 1B, so 1A, 1B, and in same manner fix 2. So 2A, 2B. Now you can see that this left coordinates are from the first set, that is A, and this right coordinates are from the second set, that is B. So A cross B equals to this, and it contains 4 ordered pairs. Note, now see, A cross B is not equals to B cross A. So that means it is not commutative. We cannot change the order of A cross B, okay, and the answer will be different. And this is important. Now what is a power set? Okay, so let capital S be any set. Now set of all subsets of S is called a power set of S. Okay, so it is denoted by this symbol P of S. Now for example, if we take this set A equals to 1, 2, 3, then this P of S equals to that is a power set of S. Now how to write a power set of S? That means set of all subsets. Just collect all the subsets of the given set. Okay, now power set of S contains the empty elements first, empty, then the singleton 1, singleton 2, singleton 3, then the set containing 2 elements, that is 1, 2, 2, 3, 1, 3, and last itself, so that means 1, 2, 3. Now note, now if a set S contains n elements, then its power set contains 2 raised to n elements. So that means we have the formula that how many elements will be there in the power set of given set. So as you can see that here it was A equals to 1, 2, 3. So it has to contain this 2 raised to 3 elements. That means 8 elements. So you can count it, there are 8 elements. Okay. So any set containing n elements, its power set contains 2 raised to n elements. And this is important. Now let us discuss what is a Venn diagram. Now see, the relation between sets can be conveniently illustrated by certain diagrams, and they are called Venn diagrams. In Venn diagram, what we'll do, a universal set can be represented by a large rectangle, okay, and the subsets of this universal set are represented by circles enclosed by the rectangle. And we will use this Venn diagram to understand operations on a set in next session. Thank you.